let's move on to saw blades. Sometimes it's a good idea to take a look at what's happening in the industry, just so you know what's available to you. And also, it may be good to go back over the basics and know why sawdust blades are put together the way they're put together and how they're used. If you'll pass your mouse over number 5, you'll see the first in a series of slides that I prepared to show you how the teeth of a saw blade are made. The first and the most important part is the rake angle of the tooth. This is the angle at which it attacks the wood. It would be your cutting angle if you were using a chisel. And in fact, that's all saw teeth are, is very small chisels. The rake angle is followed by another important angle, which is called the top clearance angle. This angle is extremely important because if it's not there, the chisel won't actually come in contact with the wood. It'll just sort of gnaw its way through the work. If you look at the saw blades from the side, sometimes a tooth is beveled. It's not only cut at a rake, but it has a bevel across the top. And that bevel can go right or left. Additionally, all carbide teeth are cut with a radial angle. That is, the sides are ground down, usually just 1 or 2 degrees, so they don't rub the wood. This creates, and if you'll go to number 8, this creates a clearance, so that only the cutting edge of the chisel tooth ever comes in contact with the wood. Now, if you're talking about a steel blade, like this plywood blade here, the teeth on this are actually set. That is, they're ground with a bevel and a rake, and then they are set to one side or the other. This creates the kerf, and the kerf, since it's wider than the blade body or the plate, the plate does not contact the wood. Only the teeth contact the wood. Here, this is a hollow ground planer blade. This also is steel, but on this one the teeth aren't set. Once again, the rake and the bevel are ground, but then the entire body of the blade is actually dished out on both sides, so that doesn't contact the wood. That's how the clearance is achieved on this. And of course, on the carbide teeth, like I showed you, your clearance is achieved by your radial angle. There are different grinds on the teeth, and each of these grinds, of course, do different things, and we'll discuss them a little bit. On this blade, you have some expansion slots, and what happens here is because it is the rim of the saw that is doing the cutting. The rim gets much hotter than the body itself. As the rim expands and the body doesn't, the saw blade can go cattywampus. It will start to warp and twist. These expansion slots allow the rim to expand without changing the shape or bending or warping the saw plate. In some cases, you have little copper plugs, and I've also seen these expansion slots filled with a very tenacious rubbery substance. Both the copper plugs and the rubber do the same thing, and that is they actually interrupt the turbulence that is caused by the saw plate, and they deaden the vibration, the standing wave that's set up, and you don't get that huge scream that you get when you've got tips of your blades traveling at almost the speed of sound. So those are the parts of the blade, and they're put together in different ways in order to do different things. Let's take this blade right here, number 10 on the slides. This is a rip blade. It's meant for cutting parallel to the grain. Consequently, the teeth are cut flat across the top. There's no bevel angle. There's a rake angle that is pretty steep, but as each tooth hits the wood, it peels away a long shaving of wood. One of the reasons why rip teeth have so few teeth along the sides and very deep gullets, these spaces between the teeth are called gullets, is because these teeth cut a long curl of wood that curls up inside that gullet and doesn't clear until the tooth actually goes down past the wood. If the gullet if these teeth were too close together and the gullets were too small, the gullets could actually fill up with sawdust before you the blade had a chance to exit the wood. In this case, they would become impacted and they would start heating up and burning. So rip blades, normally you can look at the side of a rip blade and you can say, oh yeah, very few teeth, big gullets, that's a rip blade, without even looking at the tooth. ATP blades, ATB stands for alternate top bevel. In this blade, each tooth is beveled in the opposite direction. This is a fairly efficient way. Each tooth becomes then a knife and slices clean through the fibers crossways. It's a good blade for cross cutting. They've also found that it makes a good blade for plywood. A lot of times ATB blades are plywood. In fact, we have a plywood blade here, which is made out of steel, and it also has a lot of teeth. In this case, the blades don't need the large gullets because the cut fibers are actually dust. They're not long curls like you get when you're ripping. So they just fill up those little tiny gullets between the teeth. Sometimes, and let's go back to this. I don't have an example here because we don't use them, but you can put an extremely steep bevel on these ATB blades, and it's called an HATB, or high alternate top bevel. This is good for stuff like plywood, especially very plywood with where you want a really smooth cut and you don't want to disturb the veneer over much and you don't want much tear out. You can also use them for some plastics. These HATB blades. The blade that most people use, however, is this combination blade, number 13 on the slides. The combination blade is actually a cross between the rip and the ATB blade. 4 of the teeth in each line, back here, this tooth, 1, 2, 3, 4, are alternate top bevel teeth. The leading tooth right in front of the big gullet is a rip tooth. Okay, it's ground flat across. So you go bevel right, bevel left, bevel right, bevel left, flat. So when you're cutting ripping, you've got around this saw looks like 10, maybe 12 teeth that'll do the ripping. That'll do an adequate job. And when you're cross cutting, you've got the alternate top bevel that'll cut across, and of course the smaller gullets in between. So you can do both, and you can do both fairly well with a combination blade. But if you're doing primarily just cross-cutting or just ripping, you'll get better results if you get a dedicated blade for that purpose. A very recent development is the triple chip blade, and this is used mostly for metals like aluminum, soft metals, especially non-ferrous metals, aluminum, brass, occasionally bronze. It's also used in melamine, plastics, but it does a fair job in wood also. You can use triple chips for a lot of wood products like MDF or chipboard. There is a version of the triple chip out called the California triple chip. This is just new on the market. It's just only in the last 5 years. And the California triple chip, and that would be number 15 on the slides, is used in miter saws, especially when you're doing commercial mitering, because you can go back and forth between wood and ferrous metals and do an aluminum frame or a wooden frame, and it leaves an extremely smooth cut. Finally, you have a hollow ground blade. Now this is a steel hollow ground blade. There is also a new development on the market that where they have carbide hollow ground. But basically, the hollow ground, still a lot of woodworkers prefer the steel hollow grounds because you can get these teeth razor sharp. This thing is actually, as you can see, I've just had this sharpened, and if I can turn it just right, the teeth will just shine. There you go. Jim Schubert does our sharpening, and he's a really good sharpener. He put a steep alternate top bevel on this, extremely steep, and then a straight flat. Well, no, there aren't any flats on this one. These hollow ground planer blades will actually cut extremely smoothly. And as I said, a lot of woodworkers prefer the steel to the carbide simply because you do get the smoother cut. Yes, it goes dull faster, but you can get a smoother cut off of these. Question. We have a question, right? What the ATP that I'm showing here has a 5/8 inch arbor? Yes, it does. And it's a Shopsmith blade. For a short time, Shopsmith put out some when they were offering the Sawsmith or the Sawsmith 2000. They offered 5/8 drilled 5/8 inch blades, which is something else I should mention. Most Shopsmith blades have 1.25 inch hole in the center, as opposed to the 5/8 inch hole that most other blades have. The reason for this is that very, very early on in the company, a decision was made to use industrial quality blades, and they had larger arbors. The reason they have larger arbors is it helps stabilize the saw. You get a lot more. Look at how big this is. This is a very, very stable blade. There's a whole lot less wobble or run out on a blade like this. Even the way we mount our 5/8 blades, you get a nice big wide washer there to help stabilize the blade. But these with less steel down close, so that there's less distortion, and the large hole, have fewer problems with run out. If you look at some of the industrial table saws like the Tanowitz, they all use 1.25 or 1 inch arbor holes. Any other questions? Okay. All right. Well, listen, guys, that is really all I have to say about saws. And apparently that's all the questions you have to ask me. So we're going to move off of this, and I'll welcome to our friends out on the West Coast who have joined us about 10 minutes ago, and I'm going to get set up, and we'll begin this all over again. We'll see you hopefully for the next Sawdust session, and before I go to my friends in the East, work safe, work well, and work to your heart's content. Thanks.